So when we study software processes, it's useful to consider uh, how they are grouped by the kinds of activities that are done or the kinds of steps that take place within a process. This slide talks about this kind of grouping or this grouping by phases. So you can classify activities by whether they have to do with collecting requirements, which is what the software system is supposed to do. You can group the activities by whether they do analysis, which is try to understand what the system is supposed to do, try to understand the problem, and so on. There are a collection of activities that have to do with the architecture and design of the solution. There are a collection of activities that have to do with the implementation, and then the deployment of the solution, and then the maintenance of the solution. So when you open a software engineering book and study it, you will see chapters typically having to do with these phases of software development. But keep in mind that um, software is not developed in an orderly manner, starting with the requirements phase, going through the analysis phase, through architecture, design, deployment, and maintenance. In other words, software is not deployed in the order by phase. We'll talk about that in the next slide. In reality, projects or software projects progress through stages, and the stages are shown on the slide here. So a typical software project will begin with an inception phase, essentially an inception stage, essentially a stage in which things are being figured out. So the approximate vision of the project will be identified. A high-level business case will be put together. A high-level scope of the project will be defined, and there will be high-level estimates with respect to how long it's going to take, how much time can be expended, and so on. Okay. Once a shared understanding of what the system is supposed to do and what the goals of the project are is achieved, the project will move into what is known as an elaboration stage. So the goal of the elaboration stage is really all around the resolution of high risks in the project. So think of the elaboration stage as a place where um, the work done is used to eliminate risk. So the vision of the system will be identified, the difficult parts of the architecture. So the core architecture, things that have to work, things that you don't understand whether they will work or not, those things will be implemented in the elaboration phase. Uh, but before that, there will also be a much more detailed requirements identification, and there will be more realistic estimates. Once the elaboration stage is done, essentially what this means is you now know after the elaboration stage how to do the work, how much it's going to cost, and now you can do things in much more of a cookie cutter or standard manner. The project will then move into a construction stage where you're simply adding features, but you know how to do them. Okay? And then finally, the project will have a transition stage where the software will be turned over to the customers to use. Now, even these stages won't happen only, won't simply happen once for each project. Essentially, these phases will happen. You can think of these phases as happening once for, say, every iteration or once for every release. So the project will cycle through these stages many times during the course of the project. So let us now look at a baseline structured methodology. So this is just an example, but it's a very good example, having been developed by IBM over many years to underpin their consulting practice, their software development consulting practice. So this structured methodology, which is the methodology described in the handout that from the book that I will give you, was firstly integrative in the sense that what it tried to do was take best practices from a variety of practitioners or well-known thought leaders in the field and put them all together. Secondly, one of its primary principles was incremental development, which is don't try to boil the ocean. Don't try to build the software system at one shot, but build it in pieces. Incremental development has pros and cons, and you should think about these pros and cons. You'll also see some pros and cons in the handout that I give you, and we should discuss this in class. The second thing about the second principle that this structured process followed was an iterative principle. So iterative is similar to incremental, that you want to build it in pieces, but iterative adds on to incremental by saying that you can revisit any of the phases at any during every iteration in the building of the system. So incremental simply means building it in pieces. Iterative means you can start with requirements and go down through deployment and testing for every phase. So if you didn't get it right this time, you could get it right the next time. The third principle is a refinement of incremental and iterative development, which is known as scenario-driven development. So scenario-driven development is also, once again, building it in pieces. So scenario-driven development is incremental. Scenario-driven development is iterative. But the idea behind scenario-driven development is that every new component that you build, or every feature that every new step that you take in the software system, any new piece that you build, will have something that the end user can see and appreciate. So every increment is user visible, so that the end user sees it, and secondly, the end user is delivered new value at every increment. The next principle that this structured methodology followed was something known as being workbook centered. Okay, so the idea was that it was not process centered. It didn't take you through a sequence of steps that you had to follow for everything. It was workbook centered, and we'll talk more about what we mean by workbook centered in a later slide. And finally, this structured methodology was object oriented, and this resulted from the fact that it was workbook centered. So there was data that this process maintained, and this data was represented in an object oriented way. All structured processes have a notion of separate roles. So this IBM process has the following roles: a customer role, somebody who provides requirements and is the person who's going to pay for the project; a business developer role, somebody from the software development team who's responsible for convincing the customer to include more features and pay more for them. There is a planner role who's a high level, who performs a high level planning role. Sometimes a planner is also known as a program manager. Then there is a project manager who does detailed day-to-day project management. And there's a team leader who does, who is a technical resource to the team and makes all the technical decisions, things like that. And also then, and also at the end of this list, you will see a set of roles in italics. Those are often, those are roles that are hybrid roles. So many companies will have what is known as a product manager. This product manager is responsible for making sure that the system they are building, which is being sold as a product, has the necessary features and also has the necessary evolution path towards adding new features. So he will, so that product manager will play a technical role in as an architect for that system, but also will play a domain expert role, where he will sort of say, in the next year or so, these are the features that will be in demand within the market, and therefore this is the order in which these features should be implemented in the product. There's also a role known as an engagement manager. This is typically used by, this is a role used by consulting companies that go out and deploy solutions for customers. So the engagement manager will be a project manager as well as a business developer. And a field engineer will be somebody who will take a product and customize it for a particular customer. So this field engineer has to be a developer, certainly, because he might be adding code or writing custom code and so on to get this system to work, but also has to be an architect because he's got to think about what the solution should be and how the pieces of the system that he has will fit together in order to solve that problem. This structured process strongly emphasizes what they call a project workbook. So what is a project workbook? It's a logical repository of all the work products. So we'll talk about work products in the next slides, but basically it's a repository where all the work products or documents that are created for a project are stored. How might it be constructed? Well, it might be text files, it might be Word documents, it might be HTML documents, it might be source code. All of those are components of the project workbook. And how might it be structured or organized? Well, you might structure a workbook by subsystem. So let's say you're building a large system and it's broken up into multiple subsystems. You could have a workbook for the whole system linked to sub workbooks for the subsystems within that system. Or they might be organized by increment. So for the first increment, you have a workbook. For the second increment, you have a workbook. For the third increment, you have a workbook, consisting of all the documents, requirements documents, project management documents, source code, all of those things. We said in the previous slide that a workbook consists of work products. So what are work products? Well, work products is just a name to capture all the things that are created or the documents that are created as part of a project. But they are not limited to just documents. They could be even things like the code, the source code for the project. And work products are typically classified by the phases of software development. So there are requirements work products, project management work products, architecture work products, things like that. One important point about work products is that each work product should capture a separate thing about the project or a separate concern about the project. This notion of separation of concerns will become clear when you see the examples of work products in the next set of slides. This focus on work products is also known as work product orientation, and this is a key concept. The idea behind work product orientation is that the software is the side effect, not the documents. In other words, by generating the right documents, the right work artifacts, or the right work products, the software will result from there. The focus is not the software, but generating the right work product at the right time. In other words, at the start of the project, the right thing to generate would be the requirements work products. Therefore, they will be generated. And that will prevent somebody from jumping directly into coding. This allows the process of software development to be tailored to the project. In other words, there is no standard process that you follow for doing the project. You, at every instant in time or every so often, you look at the project and say, what is the most important thing this project needs? What is the most important artifact that this project needs at this time? Is it a requirements document? Is it code? Is it design? Is it an analysis document? And based on that discussion or that analysis, the right document or the right artifact or the right work product will be generated. The next 3 slides give examples of work products. The work products are listed mainly to show you how each work product captures something different about the project. You have now seen an example of a prototypical structured methodology or process. Let's take a look at the key messages of this structured process, and in fact, all structured processes. So the first key message is that all structured processes recommend that the software development be done in a scenario-driven manner, which means that at each increment, new end user visible functionality is released so that the end user can validate the work as it goes along. The second key message is one of work products and work product orientation. And the idea behind this is to remove process rigidity. In other words, there is no prescribed way to build the software system, but rather focus on the concern that is most important at any given time. And that concern is captured by a separate work product. The third key message is one of management of risks. So a lot of things will be done in these processes simply in order to manage risk. One of the reasons why a waterfall process, where all the requirements are collected in the beginning, all the analysis is done, the entire system is designed and then implemented and then tested, is not a recommended process, is really due to the fact that that top-down approach, the top-down waterfall approach, is very risky and because it does not handle change well. So there are many techniques used to manage risks. The fact that the process is incremental and iterative is a risk management reason. The fact that the process is scenario driven is a risk management reason, so that you're not building anything that the customer does not want. The third risk management technique is once again the separation of concerns. That is, you're not so focused on building the system in a particular way that some element of the system, some component or some concern of the system falls by the wayside and is not appropriately addressed. The fourth key message of all structured processes is one of traceability. And traceability falls under two kinds: forward traceability and backward traceability. So forward traceability is when you have a source work product and that results in a change to or in the implementation or in the creation of a target work product. So for example, a typical source work product is requirements, and you've got to be able to show starting from the requirements what code was generated for that requirement. Reverse traceability is in fact the more important kind of traceability, which is from a piece of code you are able to tell what requirement was implemented by it. And by the way, that's just an example, the connection between requirements and code. In the handout that I gave you, there is a chart that shows the entire traceability. But the idea behind reverse traceability is something like this. And let's take the requirements to code example once again. Even though, keep in mind that this is just one example of traceability. Suppose you have a system that's deployed and a bug appears and you're asked to change a feature. Most software developers will look at the code first, say, decide how to implement a particular feature and implement it that way, and perhaps not realize that implementing the feature actually either modified the requirement or went against a previous requirement. Whereas if there was a connection between the code and the requirement, so when you looked at the code, you were also able to trace backwards to the requirement that was implemented, then you could figure out the right way of implementing a particular feature so that it was consistent with the previous set of requirements, or of rejecting a feature because it did not fit in the requirements as envisaged for the system. The fifth key message of all processes, all structured processes, is one of verification, which is there will be techniques in the process that will help you figure out whether a particular work product is being done correctly. Okay? So verification is the process of figuring out whether things are being done correctly. Validation is a related concept, but actually is actually orthogonal to verification. Validation is the right thing being done? So for example, if you were to create a design for a sorting program, verification is the program sorting things correctly. Validation is, did the requirements of the system imply that sorting needed to be done in the first place? That would be validation. Now that you've seen a structured software development process, see an agile one. The example of an agile process that we've chosen to show here is one known as XP, for extreme programming. The assumptions behind XP, or really for any agile process, is that the cost of change is low. That is, if you make a design decision or an implementation decision, the cost of backing out from it and doing something else is low. This is true for smaller programs. This is true when you use scripting languages, for example, or if you use frameworks like Ruby on Rails and so on. This might not be true for large systems, but regardless, the assumption behind agile processes are that the cost of change is low. The second assumption behind agile processes is that everyone is always available. That is, people are either co-located or constantly connected. Not only are the developers co-located or always available, but the customer or someone who can play the customer is also co-located or easily available to answer questions, provide requirements, validate tests, and things like that. The next thing is that XP and agile processes are really built around values rather than techniques. That is, the culture of the group, how the group is supposed to work, those kinds of things are more important than whether you use UML or what diagrams you use or how you test or how you validate and so on. And the values around agile processes are, once again, specifically for XP, are communication, simplicity, feedback, courage, and respect. Just like a structured process had roles, an agile process like XP has roles as well. But note that the number of roles are a lot fewer than for a structured process. So here are the XP activities characterized by the goals of each of the activities. So one of the goals of XP or Agile is rapid feedback. So in order to enable rapid feedback, which basically means that anytime you do something, it is validated right away by somebody else. Either you've written some code and it's validated by a test, or you made a schedule and within a week or two, you know whether that schedule is correct. Under rapid feedback, the activities are something known as pair programming, which is that developers will work together in pairs for any piece of code. So they will write the code sitting together. The second activity is what is known as a retrospective session. So right after an iteration or a release is complete, the team will sit together and decide, and think about what went right and what went wrong in that iteration. The third activity is test-driven development. In fact, in XP, right after the requirements are written, the tests are written. The coding is not done until the tests are written, so that when the coding is done, the tests are available to test the code with. And also the tests serve to validate the requirements. The idea being that nobody has, the requirement is not a valid requirement unless you can write a test for it. And the third activity regarding rapid feedback is that there is planning right before every iteration and release. So just before every iteration, there is planning. Then after that iteration is complete, there's a retrospective. And then before the next iteration, there is planning, and so on. The next goal of any agile process, and XP is no different, is what is known as a continuous process. That is, there are no big gaps, where during which people think, and then a huge gap, and then people actually build, and then a huge gap, and then people test. The entire process is very continuous. So people get together at the beginning of the day, they decide what they're going to do that day, they do their coding. The coding their code is immediately integrated into the build. It is immediately tested. Even design is not a long duration activity. The design is rapid, put in place through code, and if it needs to be changed, it gets changed later. So it's designed by improvement rather than by big upfront design. And thirdly, there are short development cycles. So every 2 weeks, or sometimes even every week, a iteration is complete. And then every month, every 2 months, maybe every 3 months at the latest, a release is made available to the customer. The third XP goal, or actually the third agile goal, I keep conflating the two, is shared understanding. That is, every member of the team understands the goals, the plans, the code completely. So to begin with, there are coding standards so that everybody's code looks different, looks the same. All code is collectively owned, so I can quite easily pick up somebody else's code and make a fix to it. Thirdly, the design is done jointly. So if there is any high-level design needed, it's done as a team. If there is any low-level design needed, then it's done with your pair, and so on. And then also the entire team is involved in planning. So at the beginning of each iteration, there's a plan. The whole team is involved in that. At the end of the iteration, there's a retrospective, and the whole team is involved in that, and so on. Here are the XP work products, once again characterized by phase. You will notice that there are many fewer work products than with structured processes. So now, how do you decide whether to use a structured process or whether to use an agile process? You decide by discovering what is known as the project shape, or the characteristics of the project, across 5 dimensions. The first dimension is the level of personnel. The second dimension is the amount of dynamism within the project. The third axis is the culture of the organization, whether it's a culture that is comfortable with change or is resistant to change. The fourth dimension is the size of the organization, whether you have a few developers or a small team, or a large team with tens or hundreds of developers. And the last axis is one of criticality. Is the system being built a mission critical system, such as a flight control system, or is it a system built for a system with less criticality, like a game? With respect to the types of software development personnel, or rather with respect to the skills of software development personnel, look at the notes page on these slides. They show you the characterization.